Welcome to the lecture series of Laplace transform. Today we are going to discuss about final value theorem. Look at the statement of final value theorem. If the Laplace transforms of f of t and f dash of t exist and L of f of t equal to f of s, then limit t tends to infinity f of t equal to limit s tends to 0 s into f of s. This is the statement of final value theorem. In the previous lecture we have discussed about initial value theorem. In that one we have limit t tend to 0 s tends to infinity, and for the final value theorem t tends to infinity s tend to 0. This is the way we have to remember the statement of initial value and final value theorem. Now we can discuss the proof. See, L of f of t equal to, it's given L of f of t equal to f of s is given in the statement, and we have studied about Laplace transform of derivatives L of f dash of t, that is nothing but the result s L of f of t minus f of 0. Okay, L f of t is nothing but what? F of s. So s into f of s minus f of 0. So which implies s into f of s minus f of 0 equal to L of f dash of t. L of f dash of t. Applying the Laplace transform definition for L of f dash of t. What is the definition? It is equal to integral 0 to infinity e power minus st f dash of t dt. Now look at the statement. In the statement, limit s tend to 0 s into f of s. That means we have to allow limit s tend to 0 on both sides. So take limit s tends to 0 on both sides. So what will happen? Limit s tends to 0 s into f of s minus f of 0 equal to limit s tends to 0 integral 0 to infinity e power minus st f dash of t dt. So look at the right hand side, limit s tends to 0. When you are allowing the limit s tends to 0 e power minus 0, the value is 1. So this integral will become as integral 0 to infinity f dash of t dt, because in this place only we have the s. So when you are allowing the limit s tend to 0, we can get this value is 1. So that we are getting the 0 to infinity f dash of t dt. When you are integrating the first derivative, we can get the answer is what? F of t. Integration of f dash is f of t with the limit 0 to infinity. Here the upper limit is infinity, lower limit is 0. So when we are applying the upper limit, we can get f of infinity. So instead of writing f of infinity, we can write that as limit t tends to infinity f of t. Lower limit is 0, f of 0. What is our left hand side? Left hand side is limit s tends to 0 s into f of s minus f of 0. Now look at this, on both sides we are having minus f of 0. So we can cancel these two terms. So this implies limit s tends to 0 s into f of s equal to limit t tends to infinity f of t. Okay, now look at the statement. What we have to prove? We are supposed to prove this result. Limit t tends to infinity f of t equal to limit s tends to 0 s into f of s. So now we have arrived the same, isn't it? Therefore, limit t tends to infinity f of t equal to limit s tends to infinity, so s tends to 0 s into f of s. This is the final value theorem. Look at the first question. Verify final value theorem for f of t equal to t square e power minus 3t. So look at the verification. We know that the final value theorem statement, what is that? Limit t tends to infinity f of t equal to limit s tends to 0 s into f of s. So f of t is given in the question. Given f of t equal to t square e power minus 3t. First we will go for the left hand side. So limit t tends to infinity f of t equal to limit t tends to infinity t square into e power minus 3t. Allow the t tends to infinity. E power minus infinity. What is the value of e power minus infinity? E power minus infinity is 0. So 0 into anything we can get 0. So our left hand side answer is 0. Now we will go with the right hand side. Limit s tend to 0, s into f of s. We have to find that value. So f of s is nothing but L of f of t. Okay, L of, what is f of t? F of t is t square e power minus 3t. When we are seeing the t square, immediately we have to remember that minus 1 square d square by ds square L of e power minus 3t. Okay, so for this minus 1 square is 1 only, so you need not to write that one. So d square by ds square equal to L of e power minus 3t. What is that? 1 by minus 3, that means plus 3. We have to differentiate this twice. Okay, so when you are differentiating the first time, we can get d by ds of minus 1 by s plus 3d whole square. Again we have to differentiate this, so you can take the minus 1 outside. When you are differentiating this, we can get minus 2 by s plus 3d whole power 3. So minus into minus plus, so 2 by s plus 3 whole power 3. This is our f of s. So now with the right hand side, what is our right hand side of the statement? Limit s tend to 0, s into f of s. That is equal to limit s tend to 0, s into f of s, 2 by s plus 3 whole power 3. So allow the s tend to 0. 0 and anything? 0. So this is our equation 2. Look at our equations 1 and 2. From equations 1 and 2, final value theorem is verified. Therefore, from equations 1 and 2, final value theorem is verified. What is that? Limit t tends to infinity f of t equal to limit s tend to 0, s into f of s, verified. Look at the next question. Verify final value theorem for f of t equal to 1 minus e power minus at. So this is also similar to the previous one. The final value theorem, limit t tends to infinity, f of t equal to limit s tend to 0, s into f of s. Given f of t equal to 1 minus e power minus at. Therefore, limit t tends to infinity f of t equal to limit t tends to infinity f of t is 1 minus e power minus at. Here allow the limit t tends to infinity. E power minus infinity, the value is 0. So we can get 1. Answer is 1. Now we will go with the second one. What is our right hand side? S into f of s. So first we have to find our f of s. We know that f of s is L of f of t. So L of, what is f of t? 1 minus e power minus at. So Laplace transform of 1 minus L of e power minus at. So what is L of 1? L of 1 is 1 by s minus L of e power minus at. What is L of e power minus at? That is 1 by minus a, no? So 1 by s plus a. So we can take s into s plus a. So cross multiplying this, s plus a minus s, we can cancel these two. Therefore our f of s is a by s into s plus a. This is our f of s. Now we can go the right hand side. Limit s tend to 0, s into f of s equal to limit s tend to 0, s into, write our f of s, a by s into s plus a. Here we can cancel the s. Allow the limit s tend to 0. So this term alone will become 0. We can get a by a. That is equal to what? 1. So this is our equation 2. Now look at our equations 1 and 2. In equation 1, limit t tends to infinity, f of t, answer is 1. And here limit s tend to 0, s into f of s is 1. Therefore, from equations 1 and 2, final value theorem is verified. Limit s tend to 0, s into f of s is verified. So this is the way we have to done problem under final value theorem. Thank you for watching.